Alright, and welcome back. So in the last video we just designed an inverting amplifier, and I took that and put it way up there in that corner. It's great drawing, so don't make fun of my handwriting because this was really hard. But it's our inverting amplifier, and you can see we have two resistors, feedback resistor and the input resistor, and it inverts and amplifies. That's what it does. So what I want to do now is take that amplifier and put it into Multisim. So you load up Multisim, you get a Multisim live video, and it's going to look something like that. Let me hide my outline just for a second. So what we're going to start out with is we're going to take this schematic up there, and we're going to then put it into Multisim. So it looks like we need input voltage, we need coupler resistors, and of course the big op amp. So let's go ahead and get started. Over here in Multisim, click on my analog signal or analog components. We can put a 3-terminal op amp, and that's going to be an op amp. I'm not exactly sure how it behaves, but I think it has an ideal output, and you can go as high or low as it wants. But that's the easy way out. We're going to do it the hard way. So we're going to do it with the 5-terminal op amp, because I do want you to have the experience, at least, as knowing how to power these things. It's a really difficult concept. Take the 5-terminal op amp, throw that down on my circuit, and there we go. One thing I want you to notice, if you look at this op amp, you'll see over there that we have 5 terminals, voltage output, that's obvious, and the 2 input terminals. You'll see that the positive, or rather the non-inverting input, is on the top, and the inverting input with the negative sign is on the bottom. If you look way up there at our schematic we drew it with the inverting input on top and the non-inverting on the bottom. Well, you might think, aha, Professor Thomas, I'll show you, I'll fix this. Click that. We're going to use the flip tool and then rotate it back around, and then we'll say, inverting inputs on top, non-inverting inputs on bottom. Okay, that works. Just, it's fine to do that, but be really careful. If you look now at the power terminals, the terminals on the top and the bottom, you'll see that now the top terminal, and that's the one at the top of the page, I can't point, my cursor won't capture, but at the top of the page you'll see that now there's a little bitty minus sign, and that little bitty minus sign is really important. So minus sign means that it's expecting the negative supply voltage to be in the top and the positive to be in the bottom. That's just a little bit confusing. That's just not the way we can really think about powering things. Positive on top, negative on bottom. Signals flow left from the left to the right. So what we're going to do is we're going to forget that, flip it back around normal. So we're going to keep the non-inverting input on top, inverting input and bottom, and now we can have the plus and minus sign so that the positive supply will go on top, the negative supply will go in the bottom. Whew. Just do it this way, it'll be way easier. All right, so enough of that. We need a voltage supply or input voltage, and we need 2 resistors, so we're going to do that. Resistor number 1, let's go ahead and throw that in there. It's connecting to the inverting input with a negative supply, somewhere around here. We have our voltage input source. I'm going to cheat for this and use a DC voltage source because it's going to be a little bit easier to explain the concept. So I throw that down on my schematic. That needs to be connected to ground, so connect the ground here. Going to take my input, wire it up to my resistor, wire that into the inverting input. Check. Got that done. That looks like it matches. Next, take our feedback resistor. So take the resistor, throw it back over here, wire that up. Now, it's called a feedback resistor. If you watch the video, it kind of discussed feedback. This is negative feedback, so it's taking the output, feeding that back into the inverting input. So this is applying negative feedback. Negative feedback is a super useful thing. It's actually really helpful. You're probably looking at some examples of one of the homeworks. Positive feedback is typically extremely annoying. It's something you try to avoid for the most part because you'll see examples why. So negative feedback is generally good. Positive feedback is not what you want. Unless you're doing a video. Sorry, it's getting late. I'm getting crazy. So notice we have the positive or the non-inverting input. This input up here at top, we want to connect that to ground. So I'm going to take my ground symbol and wire that up. Good to go. We could take voltage and simulate this and get everything, except that we've forgotten to power our circuit. So we got to power it. I'm going to show you a trick. If you do a lot of schematics, this will really help you a lot and make things look nice. You don't have to do this. It just makes your schematics a little bit easier to follow and read. We're going to be using named connectors. So in Multisim, connectors are, click the ground and click on this little thing that looks like a hat. That's called the connector. I'm going to put the connector hat on top of the power input here. If you double click this, See over here, this will come up. That's the name. I'm going to name this. I'm going to name it VP for the positive voltage. And that's done. I'm going to now take another connector hat, put it on the negative supply. Well, that doesn't look right. Let's rotate around so it looks a little better. One more. There we go. Double click this. I'm going to name it VN for the negative supply voltage. And that's my supplies. Let me pull it down so you can see it. All right. What I want to do now is take two power supplies and power them up. So I'm going to take a DC voltage supply, throw it over here, put ground on one end, and put a connector hat on the other end. There we go. I'm going to name this connector VP. And what that did, in Multisim's like, you have VP over here, you have VP over here. Behind the scenes, I'm going to wire this up so now they're connected, but you don't know that. You don't see that, at least you know that because you typed it. But now those are connected, and the VP of our power is connected to the VP of our op amp. Everything is getting powered correctly. So that's giving it 12 volts to the positive supply. Now we're going to create one for the negative supply. Do the same thing. Go DC voltage source, put it over here. Get a connector on top. Going to name that VN, not M. And then we're going to put ground over there. That'll work. Except this needs to be 12 volts. So again, double click if you need to get this menu up. Over here I'm going to say negative 12. And that should be supplying everything. All right, let's check our outline for a second. So what we did, we have built an inverting amplifier in Multisim. We want to find the gain. We can check this and then talk about resistor ranges and the valid input range. All right. Got my outline back. Hide that. Nope. There. So let's simulate this. Let's take a voltage probe and look at the input voltage and the voltage probe and look at the output voltage. So this is 12 volts. Let's turn that down. That's crazy. Let's turn that down to about 1.2 volts. So when I run this, I'm getting ready to hit play, and we expect what gain? Well, we have 1 kilo ohm resistor for the feedback, 1 kilo ohm for the input resistor, 1 over 1, 1k over 1. It should be 1. We should get 1.2 out. So if we hit run, we should see 1.2 volts. Negative 1.2 volts. It's negative, inverting amplifier, exact same voltage in, voltage out. This is working like we expect. It's not exact. It's a 1.2019, but that's close. It's working. So let's do something more interesting. Let's change this. Let's make this resistor go up by a factor of 10. That should give us a gain of 10. So we should now have 1.2 volts in. We should see 12 volts out, negative 12, excuse me. 1.2 volts in, negative 12 volts out. We're getting that. That seems to all be working. If we can move this down a little bit. 650 millivolts, we get negative 6.5 volts out. That all seems to be all right. So there's a question that someone posted to Piazza or maybe somewhere about the resistor ranges, and that was a really good question. So let's start looking at that. If we start taking these resistors down, I'm going to start taking them down by a couple of orders of magnitude. So it's at right now 1 kilo ohm, 100 ohms. 10 kilo ohms, go down to 1 kilo ohm. The resistor ratio is the same, so we're putting 650 millivolts in. We should see negative 6.5 volts out. You can see we're starting to get a few more errors. We're going to take this down by another factor of 10. And we start now 650 millivolts in. We get negative 2.1 out. That doesn't seem right. So do this again, and it keeps having some errors. And it's kind of the smaller resistors we go, the more errors we see. In real life, this op amp is doing its darndest to try to supply as much current as it can to keep this loop kind of all working and happy, and it just can't do it. In the simulator, sometimes what you'll run into is that when you have really big, really small resistors or voltage or anything, you start running into numerical precision errors because the simulator is trying to do this calculation. It's just saying, I can't do it. I can't keep up. It's too hard. So we go down too low, it doesn't work. Likewise, let's start going back up. Let's go back to 100 ohms and 1 kilo ohm, and that seems to work. So 100 ohms up to 1 kilo ohm, that's okay. Let's go up a little more. 1 kilo ohm and then 10 kilo ohms. 650 millivolts in, negative 6.5. Good there. Let's go up 10 kilo ohms and 100. So again, on all these, I'm keeping the ratios the exact same. Ratio RF over RF not changing. It's just the actual magnitude of these resistors or values are changing. That one still seems okay. It's not too far off. Let's go up one more order of magnitude. And now here we see, I do it, negative 6.44. Okay, that's might be okay. Depends on your tolerance level, but that's not quite right. And one more, 1 megohm and 10 megohm. And yep, it's just starting to get off. So as we start going above 1 megohm, things don't start working very good. So when you're talking about 10 megohm resistor, just so you know, that is a value of 10 to the 7th. So that's a really big number. And when you're dealing with things like, 1 and 10 to the 7th, well, that's so big that you lose some numerical position. Plug for ECEG 240. You'll start talking about that. It's a fun class. So let's go back. So basically in the order of about 1K, 100 ohms up to 100 kilo ohms, somewhere between there. 100 ohms to 100 kilo ohms, I would say, would be a pretty good range. I'm going to go back to 1 and 10 kilo ohms, excuse me. All right, so that's all working. So we talked about the resistor ranges you should use. The other thing is that this is amplifying the input signal by 10. So what happens? So 650 millivolts works. If I go back up, hey, mister. If I go back up to, sorry, my kids say that all the time, 2.1. So we should expect to get 21 volts out. Let's look. We're not. We're stuck at negative 12.5. Well, that's because we're trying to output more than the supply voltage, and we can't do that. The op amp just says, I give up. This is all I got. Now, we can change that in Multisim. We're at negative 12. We're seeing negative 12 volts there. That works. What if we change this to be a negative 120 volt supply? Oh, well now Multisim like, no problem. This op amp can do that. So you can see we're kind of railed or pinned into. We cannot go above or below our supply rails. That's kind of as much as we got. So I'm going to put that back to 12. So that kind of defines then what our input ranges are, because we cannot go above or beyond that. And then we also then are the input voltage that we have right now at 2.1. We in this circuit cannot go above 1.2 volts, because if we do, we then be trying to output something beyond our what our system can handle. So we've taken our inverting amplifier, built that in Multisim, and looked at some of the gain in terms of DC simulations. Next up, we're going to start looking at an AC time variance simulation. Thanks.